Advanced Math, Unit 8, Lesson 4, going over homework questions. Starting off with number 83. Everyone has their work out. All right, can you guys verify if this is the correct problem? F of x equals x squared minus x plus 1. Is that correct?
Yes.
And they will always give you the difference quotient they want you to use. They want you to do f of 2 plus h minus f of 2 all over h such that h does not equal 0, which makes sense because it'll be undefined if it did. Okay, you have one like this on the quiz today, by the way. Now, here is what you do. You make your big fraction. Now, I call it setting up like your skeleton of the problem, and you always do the skeleton of your difference quotient function. Maddie, put that away, please, and you're doing notes with us or going over homework questions. And then here's my skeleton here. I'm just setting up. This stands for the first function, and this here stands for the second function, and then h is in the denominator. So this is going to be the f of 2 plus h, and this is going to be the f of 2. So that's the first part of what I call the skeleton of the problem. Now I'm still going to set up another skeleton in here. Now when I go inside, which function do I look at for these both of them? I look at the what function? The f function. And in the f function, I'm going to set up my second skeleton. Blank squared minus blank plus 1. Blank squared minus blank plus 1. Where did I get this blank squared minus blank plus 1 from? X squared minus x plus 1. I just took out the x's and put in blanks. What am I going to put in the blanks for this first one? 2 plus h. What am I going to put in the blank for the second one? 2. And after that, after everything's filled in, all the meaty pieces of it, it's just algebra type stuff. H is going to stay h. I'm going to write 2 plus h times 2 plus h minus 2 plus h plus 1 minus, do not forget, I had a lot of kids forget on the quiz to distribute that negative, 4 minus 2 plus 1. All right, can anybody FOIL that all in one step? What do you get? 4 plus what?
4h plus h squared.
Thank you, 4h plus h squared minus 2 minus h plus 1. Do you guys see where the minus 2 minus h came from? Yes or no?
Yeah.
And then you can combine like terms here or just distribute the negative. I like to just distribute because it's easy for me to see what's going to cancel out. Okay, and a lot of things at this point should cancel out. What does cancel out? The 2's, the 4's, and the 1's. Leaving behind, what was that?
That's where I messed up. I didn't distribute the negative.
Okay, and that's where kids messed up on the quiz as well. So he said he forgot to distribute the negative. Please do not forget that. When you're subtracting polynomials or multiple pieces here, you have to distribute your negative. If you did 4 minus 2 plus 1 first, you wouldn't have to worry about it. Got it? All right, what am I left with? I'm going to put the h squared first. What's 4h and negative h combined to? Plus 3h over h. What can I factor out of the numerator? H plus 3. What am I left with? H plus 3 is your final answer. Definite on today's quiz as well as the test. Any questions? You guys are good? Does anybody feel even a smidge bit better? Like, okay, I kind of have a slight better handle on it? Okay, let's try a few more. Let's do 85. Okay, what is 85? Is that the fraction one? It looks complicated because of the fraction, but it actually ends up being a pretty simple one in the long run. F of t minus f of 1 all over t minus 1 such that t does not equal 1. Okay. Big skeleton, always a skeleton of the difference quotient piece. T minus 1 will just stay T minus 1. first part minus the second part. What is the first part going to be? F of what? F of t. And it's not always the same. Like the last one was f of 2 plus h. It's not always going to be t or 2 or 2 plus h. It just depends on the problem. This one's here going to be what? F of 1. Now, inside we set up our skeletons of this here. Now, technically, what's this first one going to be if they're asking me to use f of t? Is it just going to be actually 1 over t? No blanks. Now, technically, you could put a blank in, 1 over blank, and then plug in the t. It's still going to be 1 over t. All right, this one, 1 over what? 1, because the blank is where the t should go, and I put the 1 in its spot. All right, 1 over t minus 1 over 1, all over t minus 1. First unit, first semester. Do you guys remember what we called this and what we did? Complex fraction, good job. And what do we do to clear it? We multiply by the common denominator. I'm going to put a 1 under there just so you guys do not get confused. A lot of kids try to treat that as part of the common denominator, and it's not. What is my common denominator? T, T, and T. All right, what happens on the first one? Leaving me with 1 minus t over, I'm not going to distribute because I'm going to try to reduce if possible. I want it in factored form to see if I can reduce. We have a name for these. 1 minus t and t minus 1 starts with an O. Opposites. Good job. What happens when we cross out opposites? Pull out a negative. So what am I left with? Not negative t, but negative 1 over t. Good job. Do you agree wasn't that bad? Like once you understand how to work through the problem, it's not really that bad. Okay, questions before I move on to 86? No questions? '86 is f of x equals 4 over x plus 1, and the difference quotient is f of x minus f of 7 all over x minus 7. Can you guys verify that that is correct? Yes? Okay, so again, your big skeleton for the f, the big difference quotient, the bottom will always stay as it is. First piece minus second piece. What goes on the first piece for this difference quotient? F of x. What do I put here for the second part? What's nice about using f of x? It's not always nice that way, but what is nice about using f of x? I don't have to change anything. You're right. It's just 4 over x plus 1. This one, f of 7 is going to be 4 over blank plus 1. What do I put on the blank? 7. Is it making a little more sense now that we're into our third one? Okay, so 4 over x plus 1 minus 4 over what? 8? Don't forget to put the x minus 7 over 1. Complex fraction, do you guys want to reduce this first? Yes? Okay. Smaller numbers to work with, that is nice. What does that become? 1/2? And what do I multiply everything by?
X plus 1 and equals 7.
Be careful.
Wait, no,
X plus 1
and 2.
and the 2. Do I use the x minus 7? No. Okay, so 2x plus 1, 2x plus 1, 2 and x plus 1. Top fraction, what reduces? Leaving behind 2 times 4, which is 8. 2. Leaving behind minus x plus 1. Did I write that down properly in the top? Right here. No, what am I going to do with that negative? Distribute. Okay, and then at the bottom, I have 2, x plus 1, and I'm not going to distribute. I want it in factored form so that I can try to reduce. What did we say we have to do with that negative sign? 8 minus x plus 1 all over 2, x plus 1, x minus 7. What's our next step? Before reducing. Combine like terms. What's 8 plus 1? 9 minus x. I feel like I messed up somewhere. Where? Oh, thank you. Thank you, thank you. You guys are awesome. I knew something was supposed to reduce and it wasn't. Okay. All right, going back one step. Do you guys agree I went too fast and wrote a plus and we all agree it should be what? Minus. Okay, still combined, but it becomes what? 7 minus x. Now that we've fixed it, is it going to reduce? What reduces? And what are they called? And so when I reduce it, it leaves a negative. Since there's nothing but the negative at the top, what do I write? Negative 1 over 2x plus 1. Got it? All right. Are we ready? Does 88 have a list of ordered pairs, yes or no? Can anybody read them off to me starting with the negative 8 comma 2? What's next? Negative 6, 0. Like that? Okay. And it's asking on this one, true or false? This set of ordered pairs represents a function. This is a function, true or false. Do you guys remember the definition of a function? Yes. The vertical line test. Do you guys remember that? Do you remember how to say that in words? For every x, there is only what? One y. For every x, there is only one y. So you can't have x going to 5, or like say x is 2. You can't have 2 going to 5 and 2 also going to 3. So look, I don't care if the y values repeat, but the x values cannot. So that's all we're checking. Negative 8, negative 6, negative 4, negative 2, 0, positive 2. Did any of the x values repeat? So is it a function? True or it said it is a function. Is that true or false? True. Do we care if the y values repeat? No, that's the horizontal line test. We're going to learn that next week. Right now, for a function test, we do not care. For a function, x cannot repeat, which it does not in this set of ordered pairs. Therefore, when it says it's a function, that is true. Are we good? Okay, go ahead and put this aside. Make sure if you didn't get it done originally, you get it done this weekend. And what was 8-5? Was that the even odd stuff? All right, I'm going to go through this one kind of quickly because I do want to start the quiz. Okay. I will tell you this. On the quiz today, the problems I just went over, the difference quotient, that is there. Old stuff is there. This right here is not. Are you guys okay if I go over questions here for another day? Did you guys have questions here? Not really? Number 2? Okay. Never mind. All right. These even, yes.
Oh, we're like on 75 and 76.
On the homework questions? Yeah. Was that the one with the ordered pairs?
Yeah.
Okay, so that was like the even odd business.
Oh, that's it?
Yes.
Oh, that'd be easy then.
Okay, so even odd is on today's quiz. Did you guys understand how you plug in x and negative x? Yes? And if it absorbs the negative like cosine used to, we call that even. If it kicks the negative to the front like sine used to, we call that odd. Now, when you kick the negative out to the front, meaning you factor out, this is where kids messed up on the quiz. When you factor out the negative, what is left inside should be exactly the same as what you started with in order for it to be odd. Is the inside exactly the same as what we started with? No, that's why it's neither. We kicked the negative to the front by factoring it out. What's left over should be exactly the same. Do you see that negative sine x is the same as the sine x? So the negative came out, but it did not say the same inside. Therefore, it is neither. Any questions?
Is it like the opposite? That's even?
Yes. Well, no. The same is even. The opposite's odd. So the same is even. I got x squared minus 5, and I started with x squared minus 5. I didn't have to factor out a negative.
But if it was negative x squared plus 5.
Right, right. If you ended up with negative x squared plus 5 and factored out the negative, you see how the inside's the same as what you started with? That would be odd. That wouldn't happen on this type of problem, but as an example, yes, that's what it would be. Did you guys understand about the testing the images? When it's even, it folds on the y-axis, and when it's odd, you turn it upside down. Yes? Parabolas, absolute values, all of those, it doesn't matter if it's up or down. Sorry, that's a bad parabola. Is even. Are all parabolas even? No. For example, if I put a parabola over here and say this is 5, it's symmetrical around 5, but is it symmetrical on the y-axis? No, so that would be a neither. In order for a parabola or an absolute value, in order for it to be even, the vertex has to be on the what? The y-axis. Any questions? We're good? Okay. All right, let's get ready for our quiz.